Hi students, in the previous video, I have talked about the concepts of rates of change. So in this video, I'm moving on to the connected rates of change. So do get a pen and some papers and practice along with me. Let's do a recap of what rates of change are all about. Supposing you have given the area of a circle and it is changing at a rate of 2 centimeters squared per second. Right, what we're saying is that when the time is equal to 1 second, the area of the circle is 2 centimeters squared. When time is equal to 2 seconds, the area of the circle is 4 centimeters squared. So we're going to convert that into the mathematical symbol. It means that if I'm going to let the area of the circle be A, what this 2 centimeters squared per second means the A over dt. Let's have another example. Supposing I'm given that the velocity is changing at the rate of 80 meters per second. And if I'm going to let the letter V to represent velocity, then if to convert 80 meters per second into the mathematical symbol, it will be dv over dt equals to 80 meters per second. Likewise for the last one, supposing I let the volume, it could be the volume of a balloon or any spherical shape. If it's decreasing at the rate of 26 centimeter cube per second, what it's saying is that when s is 1 second, it's 26 centimeter cube, but when s is 2 seconds, it becomes smaller. That is the meaning why, that is what it means by decreasing, because it's getting smaller and smaller, it's deflating. So to convert that into the mathematical symbol, it means if I'm going to let the volume be V, it means dV over dt is negative 26 centimeter cube per second. Making connected rate of change is actually quite a fun thing to do. Once you kind of understand the concepts, and then if you get a hang of it, you'll find that this is actually quite an interesting topic to work on. Supposing you want to find the rate of change of the volume, that means you want to find, supposing you let the volume be V, so you want to find the rate of change of the volume, that means you want to find dV over dt. Alright, you can actually find it by taking dV over dr. That means you differentiate V respect to r, and then you multiply by the rate of change of radius. And you get the dV over dt. So what is happening is that, you see, there are two terms you have to work on. Something times something, right? And then your dV will be the numerator of your first term, and your dt will be your denominator of your second term. This one will be numerator of the first term, this one will be the denominator of the second term. And then these two, it can be any kind of variable you want. It can be dt, it can be ds, okay, whatever variable that you're given in the questions. Okay, let's do another example. Supposing I want to find the dV over dr, rate of change of V respect to R, then basically you can get it by finding the rate of change of V times the rate of change of R, but it's inverted. Okay, so that you can see that this and this can just cancel off. So what you're getting is dV over dr. And again, like what I mentioned earlier on, this one need not be dt. It can be just any variable that's given in the question. Right, let's look at the third one. Let's say if you want to find the rate of change of R, then you can basically just get it by taking the R over dA times dA over dt. You can also write it as dA over dt times dR over dA. See, you still get back your dR over dt. Okay, right. So you may have to practice a few more times before you can actually get a hang of it. Right, let's look at question 1. In question 1, we're given y equals to 3x squared over 1 plus x. And you're given the rate of change of y is 4 units per second. And you're asked to find the rate of change of x when x equals to 2. Now remember, this is a chapter that we are doing using the concepts of differentiation. So most of the time, we will just need to differentiate y respect to x. So the expression is given to you, the equation is given to you, right, is in fractions form. So therefore, we will have to apply the quotient rule to differentiate, to find our dy dx. Before anything else. All right, so let's do it. So let u equals to 3x squared and let v equals to 1 plus x. So you differentiate u respect to x will be, differentiate x squared will be 2x. This one here, that will be 3 times 2x for your du over dx, which give you 6x. So this one is basic differentiation, which I don't think I will want to explain in detail. You can refer to the earlier videos, okay, if you're still not too sure about applications of quotient rule or product rule. And then differentiate v respect to x. You differentiate 1, you get 0. Differentiate x, you get 1. So dv over dx is equals to 1. And then write down the quotient rule. Right. Plug in the values for v, du over dx, so on and so forth. Right. Simplify it and factorize it. So that is our dy dx. You will surely need to use it. Because remember, this is a topic on connected rate of change. Connected rate of change. And if you were to refer to the earlier slide, right, making connected rate of change, you will need to have different rate of change to multiply them together to get what you want. All right, so after finding dy over dx, right, okay, the next thing is that we need to understand what it means by rate of change of y. Okay, wait. So it says that x equals to 2. Let's try to find dy dx first when x equals to 2. All right, so this is the preliminary steps that we need to do before we go on to officially find the connected rate of change. All right, so that keep the value first, and then the next thing is what do we mean by the rate of change of y is 4 units per second? Yeah, it means the y over dt is equals to 4 minutes per second. So you must be able to convert all these English words into mathematical symbol. All right, and then what are we supposed to find? We're supposed to find the rate of change of x. Yes, we need to find the x over dt. Right, so we need to form the connected rate of change for the x over dt. Right, so basically, if you're to remember what I have mentioned earlier on, right, you'll be comprises of two terms, something times something, and then the numerator will be your dx. The numerator of the first term will be dx, and then the denominator of the second term will be dt. So in between, you just fit in whatever variable. And if you look at what we have found just now, you can clearly see that what goes in will be just our dy. And also because I'm given dy over dt, see? So all these are hints given to you that what goes inside the empty slot there will be your dy. And that's precisely why we need to find dy over dx by substitute x equals to 2. Because we will need this thing here, right? Not exactly a over 3, but 3 over 8. Because you're finding the x over dy. Your dy over dx is 8 over 3. So the x over dy will be 3 over 8. So that will be 3 over 8 times 4. Gives you 1.5 units per second. So therefore, the rate of change of x is 1.5 units per second. It's always good to write proper statement, right? So therefore, rate of change of of x is 1.5 units per second. I'm not too sure if I've written it. Let's see. Oh no, I did not. Okay, so that's it, right? Right, let's look at the next questions. So the next questions you're given y equals to 3x plus 10 over x minus 2. X and y are positive. All right, so they have to be positive. and they vary with time. That means you are possible to get the x over dt or the y over dt. This is what it means. Given that the rate of increase of y is twice the rate of decrease of x, find the value of y. Okay, it may seem confusing. What do you mean by, the rate of increase of y? What do you mean? And then twice of what do you mean? Right, but don't worry, okay? Remember what I've said earlier on. This is the topic on differentiation, and all the time we're actually finding the y over the x. Right, so this is the first thing we need to do. That means we always try to do what we can do first and worry about what we cannot do later. Okay, so we can just find dy over dx using quotient rule. So let's do it. So let u equals to 3x plus 10, let b equals to x minus 2, and then you differentiate it accordingly. Right, then write down the formula for the quotient rule, plug in all your v du over dx, plug in your u dv over dx. I have done a video on that, so I'm not going to go into details on how you can find your dy over dx. All right, and then we're just going to keep that. Don't worry, keep that. Okay, so we have done what we can really. The next thing is that let's tackle on the difficult part. Right, so it says that the rate of increase of y. So what does it mean? Right, it means dy over dt, right? Yes, it's twice the rate of decrease of x. So what does rate of decrease of x means? Right, it means the x over dt, but it's decreased. So that's the reason why you need a negative there. All right, the dy over dt is increased, so there's no, it's a positive value, but we don't need to write the positive value. The rate of decrease of x is negative value, so make sure you have a negative. Okay, so how do we put these two together? Yeah, they're connected by an equation where your dy over dt is 2 times, okay, your negative dx over dt. So that's form of equation. And what's the next thing you can do? The next thing you can do is, how do I end up like that? Yes, because you see that this and this can goes off. That means you can actually multiply by dt on both sides. That is the beauty of the equation. You just make sure you do it on both sides, the left and the right. So once you have done that, it's gone already, and you're left with dy equals to 2. You put the negative in front already. You're left with dy equals to negative 2 dx. And then we're going to divide by dx on both sides. So that ends up what I have there. Okay, and of course dx over dx gives you 1. 1 times negative 2 is negative 2. And where do I get this piece of information? Yes, it's what I've done earlier on. So I can plug the value in. Okay, and then I can just take both of them are negative, so just multiply by negative on both sides. So you will get 2 divided by 16. Sorry, you just do a cross multiply. What am I talking? Do a cross multiply, and you will have 2 times bracket x minus 2 equals to 16. And then the next step is just divide by 2 on both sides. So 16 divided by 2 gives you 8. Right, so there are 2 possible values. One is positive square root 8. And one is negative square root 8. All right, so we need to simplify your square root 8. Okay, because this one is not a topic on search. So simplify square root 8. You will get 2 square root 2. Basically, square root 8 is just square root 4 times square root 2. So square root 4 is 2. So that gives you 2 square root 2. Okay, and then x can be, but since we are told that x and y are positive value, that means x must be more than 0. You reject the negative value. So x will be 2 square root 2 plus 2. And we're not done yet because you're supposed to find the value of y. So we need to substitute this value of x into where? Yes, into our this equation to get the values of y. Okay, and we're not done yet because we need to rationalize it with, I think maybe simplify it first. Oh, rationalize it. Okay, okay. I thought I simplified it because you see there's a 16 and 2, right? You can actually divide by 2. But anyway, never mind. We rationalize it first with square root 2 over square root 2. Then you can just factorize 4 out from the numerator. And then you end up getting this. Okay. All right. So I hope now you're more confident of solving this kind of questions, making connected rate of change. Right, in question 6, you're given that water is pumped into an inflated rubber sphere. Right, so you need to have some imagination now. You need to imagine inside your head as a sphere and it's rubber, because rubber is elastic now, so it can get bigger and smaller, I suppose. It's stretchable. All right, so you put water inside at the rate of 0.03 meter cube per second. So for part I, what we need to do is to find the rate of change of the radius when the radius is 0.9 meter. So that means when the radius is 0.9 meter, right, what is the rate of change for the radius? And for part 2, what is the rate of change of the surface area when the radius is 0.9 meter? And part 3, we need to show that the s over dt, that means rate of change of s respect to t, it's directly proportional to 1 over r. All right, so remember what we said earlier on. Okay, whatever we can't do, all right, we don't worry too much about it. Okay, seriously, we don't worry. We just do whatever we can do. So what is it that we can do here? Yes, a sphere. We're talking about volume. We're talking about surface area. So that will link us to having the formula to find volume of a sphere. Agree with me? Right. So let's write down the formula to find volume of a sphere, which is 4 3rd pi r cubed. So let V represent the volume of the sphere. So V, so you're given, yes. So we need to first of all represent this. Okay, you need to represent this one into a mathematical symbol. So if you let V be the volume of the sphere, then this one will represent dV over dt. So you must be able to do this. Very important. Okay, you must be able to rewrite 0.03 as dV over dt. Right, then the next step is that we can write down the formula to find volume of our sphere. Right. And like what I've mentioned earlier on, this chapter is on differentiation. So we do a lot of differentiation. We keep differentiating using quotient rule, product rule, or power rule, or chain rule. So here it's easy. We just use power rule. We just find dV over dr. Okay. And then we're supposed to find the rate of change of the radius. Yes. So at r equals to 0.9, that plug it in to find your dV over dr, because we'll surely need to use that value. Okay, keep that. Okay, keep that first. And then we need to find the connected rate of change for dr over dt. Okay, which is easy. Remember I told you? Right, dr will be the numerator of the first term, dt will be the denominator of the second term. Then what do you fill in the blank? So if you look at what we have found earlier on, right, it's quite obvious. You see, I'm finding dV over dr. I'm given dV over dt. So it's quite obvious that the empty space, that the blank that I need to fill in will be your dV. Okay, and we have found dV over dr earlier on to be 3.24 pi. So dr over dV will be 1 over 3.24 pi. And multiply by 0.03, and that gives you 0.00295 units per second. That will be the answer for part I. Express a three significant figure, right? Okay, let's look at part 2. So part 2 is to find the rate of change of the surface area. So what is the formula to find the surface area of the sphere? If I let S to represent the surface area of the sphere, then S will be 4 pi r squared. Alright, so that's fine. Let's differentiate S with respect to R. So the S over the R will give you 8 pi r. Let's substitute radius to be 0.9. Okay. Alright, we keep the value. So we need to find the rate of change of the surface area. Means we're finding the S over dt. So what goes inside the blank? I'm very sure you know the answer. Yes. Okay, so we found the S over the R to be 7.2 pi here. So substitute inside there. The R over T, we found it earlier on. Right, but please do not use 0.00295 because 0.00295 is your final answer. Express a 3 significant figure. For your working answer, it should be at least 4 significant figure. So you should be using 0.002947 so that you can get an accurate answer of 0.0667 meters squared per second for your rate of change of your surface area. Alright, so let's look at part 3 here. So we need to show that the S over dt is directly proportional to 1 over r. That means what we are saying is that I can write the S over dt equals to a constant k times 1 over r. So how do I do it? Right, so the S over dt is the S over the r times the r over dt, and the S over the r is 7.2 pi. Okay, so for the r over dt, we are not going to use this because if you're going to use this one, right, you won't be able to see k times 1 over r. So you have to tweak it a bit. By substituting 1 over 3.24 pi times 0.03 for the r over dt, because earlier on your dr over dt is the r over the v times dv over dt, and the r over the dv is this value here, and dv over dt is this value. So you just leave it as the original form. Okay, original form. So that, why do you want to do that? Okay, so that you end up getting this pi, and this pi goes off, and you can just get a rational number 1 over 15, and you can rewrite it as 3 over 50 times 1 over 0.9, because your 0.9 is the radius of the circle, the radius of the sphere. You see, the purpose is that, okay, to show that the S over dt is directly proportional to 1, this is what we need to show. You see, this is what we need to show. So that means what we need to show is equals to k times 1 over 0.9. So I need to force out my 1 over 0.9. Okay, this is forcing out. I need to force this value out. And how do I do it? You just take 1 over 15 divide by 1 over, okay, very confusing. I think my explanation sucks, man. Okay, sorry. Let me try to explain again. So, okay, first of all, okay, let's erase all this. What we are trying to do here is to show that your ds over dt is directly proportional to 1 over r, means to show that the s over dt is equals to k times 1 over r. K is a constant, and your radius is 1 over 0.9. So what we need to have is we need to have 1 over 0.9 there, and also a constant k. So therefore, I cannot substitute dr over dt to be this value. So because I want to get rid of my pi here. So I need to leave the r over dt as the raw form that I had earlier on in part 2. So that this and this cancel off, so that I will work out to get a rational number, 1 over 15. So that means my 1 over 15 is equals to k times 1 over 0.9. So my k is 1 over 15 divided by 1 over 0.9. And that gives you 3 over 50. That explains how I get this 3 over 50 here. So I can actually write 1 over 15 as 3 over 50 times 1 over 0.9. And 1 over 0.9 represents my 1 over r. And 3 over 50 is my constant k. So therefore, what I've done here is I've successfully write the s over dt equals to k times 1 over r. And from there, I can conclude that the s over dt is directly proportional to 1 over r. Okay, I hope you can understand what I'm trying to explain. Right, let's look at the second last question. Right, this is a very interesting question. So you're given a lorry and a helicopter. Right, so the lorry is represented by the letter L. All right, so it's traveling along the expressway. And the helicopter is represented by the letter H, and it's flying horizontally along the path of the lorry and is vertically above the lorry at a height of 270 meters. So the helicopter flies at a constant speed of 50 meters per second. Find the rate of change of the distance between the helicopter and the lorry when x, the horizontal distance between them, is 144 meters. All right. In managing this kind of question, right, first of all, we need to understand what are the constants and what are the variables. Constant meaning something that's fixed, does not change. Variable means something that's changing. So which one is the constant here? Yes, so the constant here is actually your 270 meter. It's the height between the helicopter and the lorry. That one is fixed at 270 meter. So what is changing is your x, the horizontal distance of the helicopter and the lorry. Because when the lorry moves, the helicopter also moves. So x, that is the one that is changing. And another variable, another dimension that's changing will be your distance HL. So when you're managing this kind of questions, it's very important to know which one is changing and which one is fixed. And if you look at the diagram carefully, we are working on a right angle triangle. You can see the 90 degrees here, the right angle triangle. So of course, when you talk about right angle triangle, you will think about Tokaso, you think about Pythagoras theorem. And of course, Tokaso is not wrong, just that in this context here, we won't be using Tokaso. It will be more appropriate to use Pythagoras theorem. So how do we go about doing it? So we're going to let the distance HL be the letter S. And we're going to form the Pythagoras theorem using S, X, and 270. Okay, but before that, let's understand what's the meaning of rate of change of the distance between the helicopter and the lorry. So what is it that we're actually finding? Yes, we're actually finding the S over dt. The distance between the helicopter and the lorry is represented by the distance HL. Okay, so we need to find the S over dt. Then the next thing is that I'm going to let S to represent the distance between the lorry and the helicopter. And we're going to use Pythagoras theorem to form an equation involving S, X, and 270. Yes, so S squared is equals to X squared plus 270 squared. And we're going to make S a subject. Why we want to make S a subject? Because we will have to substitute X to be 144 later on. You see, when X is the horizontal distance, which is 144. So if you're going to make X a subject, then I need to substitute X to be 144 into this equation to find my value of S. Okay, so therefore it's very important that you need to make the right variable the subject of your equation. Okay, in this case here, because I'm substituting the value of X into the equation, I should be making S the subject instead. So I should be finding the S over the X and not the X over the S. Alright, so here I need to apply chain rule. So the S over the X will be half times bracket X squared plus 72900, that is by squaring 270, and then half minus 1 gives you negative half times differentiate this, differentiate X squared, you get 2X, differentiate 72900, get 0. And then your half and your 2X can simplify further to get X. And change this to positive index. So that is 1 over square root X squared plus 72900. And I can now substitute my X to be 144. Can you see? When the X is 144. So now I can substitute your X to be 144 to find my ds over dx. Okay. Then the next thing is that, yes, we already agreed we need to find the s over dt, right? So the s over dt is equals to the s over dx times the x over dt. So the s over dx is 8 over 17. And what is the x over dt? The x over dt is given here to be 15 meters per second. But why is it a negative value? Because you're actually moving, if you see the helicopter, you're actually moving from left to right. So the helicopter is actually moving faster than the lorry. So therefore, the distance between them is decreasing. Because the speed of the helicopter is faster than your lorry. So sooner or later, your helicopter will overtake your lorry. So therefore, the rate of change of the distance, the HL, is decreasing. So that explains why there's a negative sign there. Okay, so we need to write it using proper statement, because you need to answer to the question asked. So the question asked for the rate of change of the distance. So therefore, the rate of change of the distance between the helicopter and the lorry is negative 23.9 over 17 meters per second. Right, let's look at the last question. So for the last questions, we have a ladder PQ, and this ladder is sliding down the wall. Right, so you have to imagine, do a little bit of imagine what it means by sliding down the wall. Right, so it means that the ladder will move down some more, keep moving down until finally maybe it rests on the floor. So there are two things we need to concern ourselves with. Is, for example, if this ladder at this position, right, then we need to worry about this distance here and also this horizontal distance. These are the two distances that are changing. The one that is fixed would be the length of the ladder, which is 6 meters. Okay, the length of the ladder will not change at all. Okay, whether it lies on the floor or is leaning against the wall. It's still the same ladder you're talking about, so the length is fixed at 6 meters. So what happened is that at one point you're told that this one here, your P is 4.8 meters from the ground. and then you're asked to find the rate of change of the top of the ladder. That means you need to find at P equals to, when P is 4.8 meter from the ground, all right, if you let the height of your point P from the ground be h, you're finding the h over dt. That's what it means. So let's look at how the position of the ladder will look like. Yeah, so when your P is 4.8 meter above the level ground, okay, you need to find dh over dt. Right, so if you're going to let, just now we said there are two things that's changing, right? This one here that's changing, the height of P above the ground, and also this horizontal distance, the horizontal distance of point Q from the wall. If you're going to let it be represented by x, then the x over dt is given to be 0.6 meter per second. This is what it means. Okay, so if you let L represent the length of the ladder from the wall, this one, then your dx over dt is 0.6 meter per second. Hey, sorry, let it be L, not x. Because I let it be L. So we're talking about this distance is L. So the L over dt is 0.6 meter per second. And then we can actually, if you look at this diagram, it's similar to the questions we have done earlier. It's a right angle triangle, so we can apply Pythagoras theorem here. Yes, before that, let h represent the height of point P above the ground. Right, so this is how your right angle triangle will look like. Okay, so at this point here, we need to make a decision whether we should make L the subject or H the subject. Right, but because we're substituting your P, we want to substitute at the point when P is 4.8 meter from the ground. That means we want to substitute H to be 4.8 meter. When H is equal to 4.8 meter, we need to find the H over dt. So therefore, we should be making L the subject. Okay, we should be making L the subject. So we should be finding the L over dh. Can you see? So that ultimately, I need to substitute my H to be 4.8 meter. If you make h the subject, then you have to substitute your h equals to 4.8 meter into this equation to find your L, and that is more steps. You incur more steps, which we don't want to do that, because the more steps you make, it waste time, plus you may make more mistake. All right, let's look at the next slide. We stop here and look at the next slide. Right, so we have managed to find the L over dh at the earlier slide to be negative h times bracket 36 minus h squared to the power negative half. So we're going to substitute our height to be 4.8 meter, and you end up getting negative 4 over 3. Then we need to find the connected rate of change for our dh over dt. So our dh over dt is just dh over dl times dl over dt. Alright, so dh over dl will be the inverted of this, which is negative 3/4, and we're given dl over dt to be 0.6. So therefore, the rate of change of the height will be negative 9 over 20 meter per second. And it makes sense because the height of point P is getting smaller and smaller. When it slides down, right, the height gets smaller and smaller, it's decreasing. But your L will get bigger and bigger, right? So that's answer to the question asked. So the top of the ladder is sliding down. So when you use the word is sliding down, then you do not put the negative here. You do not, because the word sliding down already indicate it's a negative value. It's decreasing. It's already indicate it's a decreasing value. It's a negative value. So you don't put any more negative at your answer. So the top of the ladder is sliding down at the rate of 9 over 20 meter per second. Okay, so this is how you solve the last question. All right, so happy doing your homework.